So, hi, I'm Gio. I'm the Cybersecurity Marketing Manager for Asia Pacific at Cisco. So, with me today is Jorge, who's going to be talking about secure workload. So, Jorge, 20 minutes, the floor is yours. Please knock yourself out and knock all of us out.
Thank you very much, Gio. So, my name is Jorge Quintero. I am a technical marketing engineer for Cisco Secure Workload and Cisco Secure Firewall. It's very good to be back live again, and especially talking about these new innovations that we have, especially with the Secure Workload and Secure Firewall integration. So, let's take a little bit of a step back here and let's talk about the technology evolution, right? How it has evolved during the last 3 decades. We first started with the application deployment on these bare metal monolithic applications. Then the virtual machine innovation came in, offering application owners flexibility to deploy their application in these application tiered deployment models. Then the public cloud came in, offering a very innovative way to consume these application workloads on the cloud, right? Offering you this abstraction of the physical and networking layer where you could host these applications on the cloud and you just consume it on a subscription-based model, right? Very convenient where you don't have to deal with these physical and network complexities, just focusing on the applications and the resources you consume, such as compute or storage. Then microservices revolution kicked in. And we can say nowadays that Kubernetes has reached a certain level of maturity where the majority of startups and small companies are already leveraging this new architecture, but the bigger companies, right, they are either starting the journey, right, starting to prepare which applications they can start to migrate to this new microservices architecture, or they already migrated some of them. And lastly, we have serverless, which changed the paradigm of how we consume application workloads in the cloud service provider. Now the cloud service provider abstract even the operating system layer, offering you the language runtime of your choice, so you can focus writing in the language that you mostly use, right? It can be Python, Node.js, or JavaScript, without caring about the underlying operating system. So what's the message here, right? And we can see that with all of these technology transitions, there is a shift and lift, right? This is often referred to as the 5 Rs: rehost, replatform, uh, rehost, replatform, um, retain, retired, and refactor. So how this is done is up to the business, right? It's up to the company to evaluate how to modernize their applications and the cost associated to it. But the key challenge they face here is how to secure all of these new constructs, right? And at the end of the day, it's a shared responsibility between the NetSec teams and application owners to secure both the network and the applications. And here's where we start talking about the policy control and organizational challenges, right? You need several people to run the company and to protect it, starting with the NextSec teams, right? They are usually these traditional responsible people of having the policy definition and policy execution of policies, right, to implement these security controls in the environment. And they typically use these constructs such as firewalls, next generation firewalls, or load balancers, just to mention a few. Then you have the server or VM security, which this responsibility for some companies are already shifted to the NextSec teams, or at least the policy definition, while the policy execution is within this VM or server admin, which can be the application owner if they own the workload form factor. So you can see that there is this shared model of security. Now, this persona, this server or VM admin, they usually use these constructs already available in the host native operating system, such as Windows firewalls, Linux IP tables, or AX IP filters. Then you have cloud security, which is owned by the cloud architect. And this responsibility may or may have not shifted, right? Depends on the company, but there is a shared responsibility here. And these cloud architects, they're already using some cloud native constructs in the form of security groups. And finally, we have cloud native security. And here's where I usually ask my customers if they know what DevSecOps or DevOps persona, what they're doing here. And this is usually a black box for them, right? They use more different set of tools and they're more complex constructs. They usually use Kubernetes network policy objects or CI/CD workflows to secure the environment. This responsibility may eventually shift to the next team, or it will be a shared responsibility between the two of them. And here you can see it clearly, right? We have different people, different processes, and different technologies. And of course, you're having multiple teams, organizations, and environments using different set of tools and processes, and this leads to this inconsistent island of policy controls where attackers thrive because of these missing security controls, right? These missing security gaps, and they can breach and access the crown jewel of the company. And this, of course, leads to the theme of the session, the policy puzzle, right? And this is precisely what Secure Workload tries to address, having a solution that offers you full visibility of workloads and networks, have a comprehensive policy lifecycle toolkit, and adapts to the organizational structure, processes, and personas. Now, what we have done here is that we have mapped Secure Workload to the NIST 800-207 architecture as a reference, right? Showing you how you can achieve with Secure Workload, zero trust, microsegmentation. Starting with the visibility, right? Ingesting telemetry information from host-based sources, cloud-based sources, or network-based sources, as well as users. You also ingest context, right? And we have a flexible approach to ingest context to give this visibility to your workloads, right? In the mean of meaningful labels. This can be up to 32 labels defined manually or ingested it through external system of records such as CMDBs or IPAMs, just to mention a few. A comprehensive policy discovery where Secure Workload uses these machine learning and behavioral algorithms to automatically discover the policies for you, and a comprehensive policy analysis toolkit to validate, test, and verify these policies with real traffic before enforcing it into the network. And finally, enforcing this distributed allow list policy model to all of these enforcement points, right? Talking about host-based, using the host-native firewall, such as Windows Firewall or Linux IP tables, cloud-based, using security groups, or network-based, using Secure Firewall. So with Secure Workload, we fit the pieces of the puzzle all together, right? Where you have a solution that adapts to the organizational structure, personas, and processes, where the NextSec teams can have full visibility of workloads and applications, and they can ensure that these mandates and compliance and guardrail policies are in place for the application owners, and they can also ensure that these policies are deployed in all workloads and networks in the environment. For the CloudSec, application owners, or AppSec, they can be in control of the policy control of the specific applications they own using constructs such as the host-native firewall, security groups in the cloud, or even the API, leveraging common tools such as Ansible, Terraform, or CI/CD workflows. Now, with Secure Firewall, our vision is to have this end-to-end protection, right? Starting with the north-south traffic flows, where you have this very powerful, capable, next-generation firewalls sitting either in the data center edge or the cloud edge, having full visibility and performing this deep packet inspection and threat protection, while at the data center, east-west, or cloud, doing this analysis of east-west traffic flows, and you have this Secure Workload and Secure Firewall combination working in tandem, right? Where Secure Firewall will have these macro policies or guardrail policies to protect your application workloads, as well as coverage for these workloads where the agent is not feasible to install. And lastly, workload security, using Secure Workload, right, implemented these fine-grained micro policies at the workload level. Now let's have a look at the demo of how you can implement Secure Workload to secure agentless workloads using Secure Firewall as an enforcement point. So here we are in Secure Workload, right? We navigate to the scope and inventory, and here is where you will define the organizational structure of your company. For this, you will use these manual labels or ingest external system of records context, right? In this case, we're ingesting it from AWS, from Kubernetes, and from F5 load balancers. You can see how we build this hierarchical topology, right? Describing the organizational structure of the company. And in this case, I'm navigating to AWS, and we can see all of this dynamic context that is being ingested with the labels defined in AWS, right? We haven't set up any of those labels in secure workload. Now, under the US West 2 organizational structure, we can see all of the labels that we ingest for those specific agentless application workloads. Now we'll navigate to the data center organizational structure, where we will leverage secure firewall to do our segmentation policies. In this case, it's the e-commerce development application, and we can see all these contexts that we applied using these manual labels for this application. Now we'll navigate to the segmentation tab of secure workload, and here I will use a construct that we call workspace. This is how we map this organizational structure to the workspace where we will be applying these segmentation policies. So as you can see here, I put a meaningful name for the workspace, and now we'll select the organizational structure for this application. And this is how you can delegate policy controls to specific personas. You can see that there are no policies defined whatsoever for this application. So I will navigate to the inventories tab. We can see all the workloads that are belonging to this application, and we will discover the policy automatically using secure workload, machine learning, and behavioral algorithms with the feature called application dependency mapping. And as you can see here, I'm just running a very small time frame, but you can run it for 6 months, for example, or 8 months. So you have all of this toolkit at your disposal to generate these policies, right? And analyze, for example, for seasonal flows, right? If your application have some specific type of flow patterns. Now, once they are produced, we navigate to policies. You will have this traditional access control list display or this nice policy canvas, right? Where you can see how the application behaves. How are the intra-application communication between the different tiers of the application, the query, right? The labels that are associated with these workloads, and of course, the application to the external world. We can see different services such as NTP and DNS, as well as users. We can see here, for example, the contractors that are how are accessing our application. In this case, using port 22 and port 80, accessing the SQL and front-end tier of our application respectively, as well as the administrators that are accessing the application tiers. Now, this is not only limited to data center, right? As I said before, we have all visibility of these workloads regardless of their location, right? We're talking right now of our application that is sitting in data center, but we can see that it's communicating with some other workloads, in this case in the cloud, that is having some communication with the database cluster out there. So you have all of this visibility for your applications. Now, we set our zero trust microsegmentation policies, right? As you can see here, this is the allow list policy model that we will be employing in all of these enforcement points, in this case, secure firewall. But before that, we want to make sure that the policies reflect our intent. And here is where we run policy analysis. So we will run these segmentation policies against real traffic that we're observing in the network to see how it behaves. You can also run what-if scenarios, right? If you want to, be sure that a specific traffic flow is not being blocked. In this case, we're checking a traffic flow that is being allowed. And if we do a quick policy analysis, we can see the matching policy that in this case is the front-end traffic to the WordPress cluster, right? This is intra-application communication. Now, I'm interested to look into escape flows, right? These flows that should have been dropped, right? Because they are not defined in our policy, in our allow list policy model, but somehow they're not being enforced, right? Because we're not enforcing yet the policies. And here we can see how the contractors, which are accessing the database cluster using port 22, which they don't have any need to know access, right? They shouldn't be accessing this. They are still able to access the database tier, right? And that's why it's marked as escaped, because it should have been dropped by the deny catch-all rule. Now, once you define the policies, validate them, then you proceed to do the enforcement. For this, we click on the enforcement tab, we select the policy analysis, in this case, the version 1, and we proceed to do the enforcement. And with this, we're pushing these rules to the secure firewall. Now, I will navigate to the FMC orchestrator. I just want to highlight some of the new features that we have added to the integration. So here you can see all the information related to the external orchestrator, but you can see as well, for example, the use secure workload catch-all rules. So now you can select either to use the secure workload rules or the FMC default policy available already in your access control policy. And you can now also select where to position secure workload rules, either on top or bottom of existing FMC firewall rules. We can also see as well the domains that we are integrated with secure workload, right? The domains that we're using to push these firewall rules. In this case, is the DC East-West domain. Now I will navigate back to FMC in this case. I will input the username and password, and I will navigate to the DC East-West domain. And if I navigate to policies, access control policy, we can see that the REST API user that is automating these policies already did some changes, and we can see how secure workload pushed all of these automated segmentation policies below an existing rule in the mandatory section, right? These are the guardrail policies. And just below it, we have our zero trust micro-segmentation policies for agentless dev e-commerce application. You can see as well that it pushed these policies on top of the existing rule, as well as the secure workload deny catch-all rules. With this, we finish our demo. So I just want to do some closing remarks with secure workload and secure firewall. And the idea here is to start having these conversations of how we can implement a zero trust segmentation strategy using both solutions. Having said this, I want to thank you. And if you want to have more information about this integration, please visit our YouTube channels for Cisco Secure Firewall and Cisco Secure Workload. Thank you very much.